Syngo MR Neuro 3D enables the post-processing and visualization of functional bold and diffusion tensor images. This e-clip will focus solely on describing the workflow for bold fMRI processing and analysis. If the assignment rules have been properly configured, the patient exam is assigned to MR Neuro 3D, and a simple double-click on the patient name will open the application. Alternatively, assignment can be performed with a right mouse click and selection of the option Open with MR Neuro 3D. For faster loading, it is possible to select only the relevant series, Bold Motion Corrected Series GLM Anatomical Data, and open as View as Read Only with MR Neuro 3D. First, MR Neuro 3D offers the possibility to align the different acquisitions to a reference scan, usually the anatomical scan such as the MPR age, in order to ensure that all data to be processed and visualized are correctly registered. This is needed if the patient has moved between two acquisitions. Alignment is also particularly useful for the analysis of data acquired in different scan sessions. For instance, different bold data sets acquired on different days for the same patient. The alignment overview displays all available series overlaid on the reference scan. This is the starting point for registration. Different overlay palettes for reference and target images, such as edges, are available to help visual assessment of co-registration accuracy. In addition, a blending functionality is available. Image alignment can be performed automatically or manually. In the Overview window, the automatic alignment functionality registers all available bold series to the reference scan. This algorithm works with an iterative approach. Every time the Auto Alignment button is clicked, this further improves the registration until a steady state is reached. For a more detailed verification of the alignment of a single series, a click on this series in Targets list will open this single series in a dedicated 3D MPR view with the functional data overlaid on the reference scan. With visual alignment, it is possible to align the images manually. The raw bold series is also displayed, and the user can scroll through the different slices with the mouse wheel and also through time with the arrows key, left, right. Graphs of motion, rotation, and translation during the series acquisition are displayed below. Another series can be selected by a click in the Target list. Clicking on the Overview icon will bring back the overview display. When all the series are properly registered, processing and visualization can then be performed. The fMRI step provides an interactive and comprehensive set of tools for the visualization of bold activation areas. In this step, all bold paradigms performed are presented in the function list, and the corresponding activation maps are displayed overlaid on the reference scan in a 3D MPR view and as a volume rendered image. The processing tools offer the following functionalities. Hide or display dedicated activation maps by clicking the eye icon in the function list. assignment of color palettes to the activation maps, adjustment of statistical threshold levels to better visualize the relevant activation regions. Different modes for visualized color palettes are available. Individual mode, where each activation map can get its own color palette. Uniform mode, where all activation maps get the same color palette. Highlight mode, where the activation map of a primary task gets its color palette and the secondary tasks get the same color palette. Option to use interpolation and to specify cluster size in the Function Properties menu. In the right bottom corner menu, select Function and the wrench of a specific task to open the function properties for this task to activate these functions. For visualization, the following tools are available in the upper left corner menu of the VRT segment. Clip plane to hide the skull, anatomical volume, and active areas in front of the cutting plane if you move it. Use the right mouse bottom to move the click plane, right mouse click on the boundary, hold mouse button pressed, and drag the plane. With different key combination, additional clip planes can activate, or existing can deactivate. For instance, Shift plus H, clip plane, head, feet. Shift plus A, clip plane, anterior, posterior. Split plane, to display the active areas and to cut simultaneously the skull and anatomical volume if you move the split plane with the right mouse button pressed. In the lower left corner menu of the VRT segment, additional visualization tools are available. The head mask displays the active areas in the skull and anatomical volume, and hides the active areas outside the head according to the defined threshold, so only interesting activation areas are displayed. The brain mask hides the head structure and only displays the active areas within the brain structure using the bold images. An additional step, image selection, is available after the alignment step. In this step, another reference series can be selected if desired, and a field map can be used. This image selection step is only available after the fMRI step has been taken. The time course evaluation step provides the tools to analyze signal time curves of the activations. This is particularly useful to perform a quality check of the bold signal pattern. To perform a time course analysis, the task to evaluate can be selected in the function list by clicking on the white box. The corresponding activation map is displayed or hidden. The eye icon indicates the task being displayed. Two tools for time course analysis are available: fMRI voxel or fMRI VOI. The drawing of a VOI or the placement of a voxel triggers the display of the corresponding signal time curve. Choose fMRI VOI and with a left mouse click to draw a VOI over the area of interest to display the appropriate paradigm curves. The VOI, by default, is restricted only to the voxels, which are activated above threshold. This can be changed with a right click on the VOI and deselection of Shrink to Activation option. Once a measurement object is created, a finding can be generated for reporting purposes with a right-click and selection of Create Neuro 3D Finding option. This will automatically create a finding in the Findings Navigator. If the findings are marked, then they will be stored in the final report. At the same time, the result is automatically added into the patient's report, which can be opened from Patient tab. The export step is used to export the processing results by creating ranges of the activation maps fused with the reference series. These results can be stored in the packs in different formats, enabling later reuse for surgery planning. To export the complete series in specific orientations, the desired segments to export have to be selected together with the format. Pressing the export icon triggers the export. Dedicated ranges can also be created using the Standard Ranges tool available in the top left corner of any segment. All results are then visible in the Series Navigator. With a right-click on the result in the Series Navigator, it is possible to export, print, or rename the series. Results are permanently saved in the packs by completing the workflow.